Hello friends, welcome to today's session of chemistry. As you all know, we have started with 8th lesson of your syllabus, that is transition and inner transition elements. We call them D block elements and A block elements. Out of these two, we have started with transition elements first, which are D block elements. We will just revise what we learned in previous sessions. We learned about the position of D block in the periodic table. We learn about the electronic configuration shown by these elements, the variable oxidation states shown by these elements, as well as the physical properties of the elements. Now, from that we can conclude that the block elements are all metals, and this block is located at the center of the periodic table between S and P block. These elements are placed in 10 different groups and 4 different periods. These periods are called transition series. The first transition series is 3D, second is 4D, third is 5D, and fourth is 6D series. Now, all these elements, as we said, that they are metals, that means they show typical metallic properties. But they are less electropositive than strongly electropositive S block metals, but they are stronger electropositive than P block elements. That means they are intermediate between S and P block. Now, in today's session, we are going to study the periodic trends in case of some atomic properties shown by the first transition series elements. So let us start. The first property is atomic and ionic radii. We will just start with atomic radii first and ionic radii later. Now, while moving from left to right along a transition series, atomic radii decreases gradually. The reason is, as we move across a transition series from left to right, nuclear charge increases by 1 unit at a time, and the last filled electrons enter a penultimate, that is n-1d subshell. What does it mean? As you know, when we move from left to right along a period, every time there is increase in atomic number by 1 unit. As atomic number increases by 1 unit, that means one proton is added in the nucleus and one electron is added in the last shell. That means the nuclear charge increases by 1 unit. But in case of D block, the electron enters not the ultimate shell but the penultimate shell, that is n-1d subshell. While moving from left to right, all the electrons will enter the same shell. That means actually there should not be any change in the atomic radii. But because the effective nuclear charge increases, hence the atomic radii decreases. What is effective nuclear charge? You see, the nucleus is added with one proton every time, while the electrons are added in the penultimate shell. That means the power of nucleus is increasing. Which power? Power to hold electrons. That is increasing every time, but the new electrons are added in the same shell. Hence, the atomic radii actually shrinks, and that means we observe decrease in the atomic radii while going from left to right. Understood? Now, in case of ionic radii also show the same trend. That means there is gradual decrease in the ionic radii while going from left to right. But these elements show variable oxidation states. So, ionic radii trend can be studied by considering two different aspects. First one is elements having same oxidation state, or second one, considering various oxidation states shown by same element. Do you understand by this? Now, in case of D block elements, you see plus 2 and plus 3 oxidation states are shown by all the elements. That means same oxidation state shown by all the elements. So what happens to ionic radii in this case? Same way, variable oxidation state same shown by same element. Then we consider example of manganese. It shows oxidation states from plus 2 to plus 7. So what happens to ionic radii when we move from plus 2 oxidation state to plus 7 oxidation considering single element? So these two aspects should be studied while studying trend in ionic radii. So let us consider first type, that is same oxidation state shown by all the elements. With an increase of nuclear charge, a gradual decrease in ionic radii was observed. That means if we consider the same oxidation state, then there is decrease in atomic radii or ionic radii, from left to right. Consider the example of chromium and copper. Both are plus 2, same oxidation state, but this is 24, this is 29. We see from 82 picometer, the radius decreases to 72 picometer. So same oxidation state shown by different element, there is in decrease in ionic radii while moving from left to right. Understood? Now the second type, that is same element showing variable oxidation state. Suppose we consider any element showing plus 1, plus 2, plus 3, plus 4 and so on oxidation states. Then with higher oxidation state, the effective nuclear charge increases and hence there is decrease in ionic radii from M plus 2 to M plus 3. Understood this? Now, if we move from plus 2 to plus 3, what is the difference between these two? One more electron is donated by this higher oxidation state, means one electron will be less as compared to this. And that means again the number of proton in the nucleus is same. But the one electron is less. That means again there is increase in the effective nuclear charge and hence there is decrease in the ionic radii. In second case, that is different oxidation states shown by same element. Understood this? So, this is all about ionic radii. Now, the second property. First is atomic and ionic radii. Now, second property and its trains we will study, and that is ionization enthalpy. You all know very well what is ionization enthalpy. It is the enthalpy or energy required to remove electron from the outermost shell. Now, the trend. The ionization enthalpies of transition series are intermediate between those of S block and P block elements. S block elements, they are strongly electropositive metals, hence they have less ionization enthalpy values, while P block elements, they are strong electronegative non-metals, hence they have higher ionization enthalpy values, but D block elements are less electropositive than the elements of group 1 and 2, that is S block, and hence they have values intermediate between those of S and P block. But these elements, they form both type of bonds. Not only ionic, but they form covalent bonds as well because they contain many number of unpaired electrons. Now, one more aspect should be studied in case of ionization enthalpy. What is that? There is substantial increase in the value of ionization enthalpy while going from first ionization enthalpy to third ionization enthalpy. What does it mean? Suppose we call first ionization enthalpy as IE1 and for third ionization enthalpy if we call IE3, then there is increase. Now, we have seen that the these elements show variable oxidation states. That means the energy required to remove first electron is I1 and energy required to remove third electron is I3. There is substantial increase. Why? Because these are metals, hence their values are lesser, but not as low as S block. They're intermediate, we call. But to remove electron from the neutral metal atom is first ionization enthalpy. It is somewhat easier. But third ionization enthalpy means we have to remove electron from positively charged ion. Third ionization enthalpy we are considering. That means while moving or while removing an electron from positively charged ion, it requires more energy naturally because positively charged ion will attract that electron and hence more energy is required. But hence there is substantial increase, unusual increase or more than expected increase in the IE3 values as compared to IE1 values. So one more question can be asked like this. The ionization enthalpies of the elements of third transition series are much higher than the first and second series. Explain why. Now, third transition series, that is 5D series. The question is why the ionization enthalpy values of 5D series are higher than 3D series, that is first transition series. What will be the answer? The answer is like this. The atoms of the elements of third transition, they have field 4 orbitals. Now, first and second transition series, that is 3D and 4D series, there are no F orbitals. F orbital or 4F electrons are introduced in the third transition series, and those are 4F orbital. As the atomic number will increase by 14 units directly. But what happens is the 4F orbitals they offer poor shielding effect. What is shielding effect? You know screening effect, semi-shielding effect. That means the inner electrons or the electrons which are there in the inner shell, they affect the nuclear charge from going to last shell. Now, centrally placed nucleus attracts the electrons in the last shell, but the electrons in between the first shell and last shell act as a shield or a screen while transferring the energy of nucleus to last shell. And hence, the energy of the nucleus gets distributed among these inner electrons. But F orbitals, in case of that, the electrons are entered in pre-penultimate shell and not in the last shell. And because of that, there is a poor shielding effect or no effect of 14 electrons which are there in the 4F orbital. And because of that, no shielding effect and hence the electrons in the valence shell or the last shell, they experience greater nuclear attraction, greater force, and hence these elements, that is the elements of the third transition series, they require more energy to remove the electron from them. So this is the answer for this question, why the ionization enthalpies of third transition series are much more higher than that of first and second series because of the presence of 4F electrons, but they are shielding effect is almost no shielding effect is there, and hence more attractive forces of the nucleus on the valence shell electron, and hence much more higher energies will be required to remove the electron. Understood? So this is all about ionization enthalpy. Now the next property we are going to study about is a metallic character. Now, metallic character, as you know, the transition elements, all of them are metals. That means they have lower ionization enthalpy values and they also have vacant d orbitals in the outermost shell. Vacant d orbitals, that means much more number of unpaired electrons are there in the last shell, and because of that all of these elements they show metallic properties. And hence, because of low ionization enthalpies and vacant d orbitals, formation of metallic bond, this tendency is more in case of these elements. Now, as we say, these are metals. That means they are hard, they have high melting and boiling point. So we should explain all these properties. Now, the hard nature of these elements suggests that they have more tendency to form covalent bonds. Because again the reason is same. There are unpaired n-1d electrons. Now, we will see about the next property, that is all of these elements whether they show the structure same as that of metals, then it is yes, the answer is yes. They show typical metallic structure like hexagonal close packed, cubic close packed, and body centered cubic lattices or crystals. That means they are again metals, we can say. About melting and boiling points, there is increase in melting point observed, while the elements like chromium, molybdenum, tungsten, they show highest melting points if we consider the series. So in the first transition series, these are the elements. Chromium shows higher melting points because it has more tendency to form covalent bonds. So it requires more energy to remove or break that. So this is about a metallic character. So next properties and their trends we'll see in the next lecture. Now this is time for assignment. You have to explain why third transition series elements show higher ionization enthalpy values as compared to first and second series. Second question is explain periodic trend in case of ionic radii shown by first transition series elements. Thank you.